All right, so let's go ahead and take a look at linear relationships. We're going to get started by writing the name linear relationships at the top. Now, linear relationships can be represented in a lot of ways. One of those ways that linear relationships can be represented is by looking at an equation, and usually along with that equation will come a graph or a table. So we're going to be looking at right now, what is the equation of a straight line, or in other words, if I have a linear relationship, I'm going to have a straight line. They all have the same formula or the same component. So when I look at this, I have y equals mx plus b. So it's important for me to be able to identify each of these variables and to be able to find them when I need them. I really enjoy this particular equation because it's very simple, but it also gives me a lot of really solid information that can help me to make some important decisions. Let's look at what they stand for individually. Well, we know that x is where we start when we're working on a coordinate grid or a coordinate plane. So x represents our x-axis, y is going to represent our y-axis, or in other words, really the coordinates where they're located. When x is this, y is this. Well, the line that goes through is represented by m, and this tells us a couple of different things. One, it tells us the slope, or how up and down our line is. So is our line more straight up, more vertical, or is it kind of more flat or more horizontal? And that tells us also something about its rate of change, or how quickly something is happening in this relationship. Rate of change comes up a lot. We can also call it constant rate of change. Then finally, I look at B, and B is going to represent my y-intercept. And when I think about y-intercept, sometimes that word intercept can trip me up, but then I can think about it a different way by writing it as y crossing. So if I think about it as my y crossing, that reminds me my B is just wherever the line crosses the major y-axis. Where does my line cross the y-axis? So, just to quickly review, if I think about my y, I'm thinking about how far up am I going on the y-axis. X, I'm thinking about how far along, so forward or backward, am I moving on the axis. Then I look at m. M is my slope or gradient, how steep the line is. Again, if I have a steep line, it's telling me that I have a quick rate of change. Things are happening very fast. If I have a line that is not steep, a line that's more horizontal, it's telling me that I have a rate of change that is slower. Then I can also look at B, which is again my y-intercept, or where the line crosses the y-axis, which is why sometimes if you're having trouble with that idea of intercept, you can think of y crossing. Now, it is important to think about how we might see our different slopes. So I'm going to show and ask that you create two coordinate planes. And we're just going to do this quick. Doesn't have to be perfect, but we just want to have some quick examples to look at and remind us that we can see this in so many different forms. So I want us to draw one line that's going down, and we're going to draw another line that's going up, straight through our coordinate grid. We're going to call this one that's going down a negative slope. So it lets me know that I'm going to be looking for negative numbers in my equation, or I'm going to be looking for a minus sign in my equation. And then I look here and I have a positive slope because my line is going up. My straight line is going up. So when I look at my equation, I'm looking for positive numbers or an addition sign. So if you can hear that, I apologize. There's somebody screaming outside my door. Anywho, let's go ahead and continue with our last piece. Finally, when we look here, we can see that we might have to do some work in order to find what our slope is. Finding b is pretty easy. Finding what our initial value is, or finding where our line crosses the y-axis, is easy because we can look on the graph and see where that is. When it comes to slope, we're going to actually have to think about it a little bit more. So we're looking for where does my line cross through an intersection neatly. And so if I count the units, let's say for instance in this case I have 5 units is my change, takes me to get from here to here is 5 units, and then I come up and this is 3 units. So I go up 3 units. So sometimes people like to call this rise over run, or change in y, change in x. So my rise is 3. I go up 3 to get from this point to this point, and then I run forward 5 spaces, or 5 units. So now I have a rate of 3/5. I could divide this to find a more specific rate if I wanted to. So now we've taken some time to quickly review what we know about linear relationships and their equations. We're going to have to apply this information in a lot of different ways as we work on some practice.